Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture. And as promised you in the last lecture, that in this lecture we will study the two approaches to describe the motion of fluid. So that will be description of fluid motion. So first approach is Lagrangian approach and second approach is Eulerian approach. So what is Lagrangian approach? In classical theory, the Lagrangian specification of field is a way of looking at fluid motion where the observer follows an individual fluid parcel as it moves through space and time. Plotting the position of individual parcel through time gives the path line of the parcel. This can be visualized as sitting in a boat and drifting down a river. Now let us try to understand the Lagrangian approach. Like we have this fluid motion consisting of different layers of fluid. Okay, and there is a boat. This is the boat in the river, and to record its motion there is camera in it. So let us say this is the particle starting from here, and the boat will be moving with the particle and camera is fixed in the boat. So this will record the motion of each and every particle. Say this is one particle following this path, other particle following this path. So this and this difference is due to the initial position of the particle. That what was the initial position of the particle, and due to that this difference has arisen. So this difference is due to initial position. Say these are the initial position for these particles. So if I say that Lagrangian motion depends upon the first point is that initial position. Like if I say these are four particles of the fluid motion, so this will have different path line. Path line means path followed. This will have different path line, this will have different path line, this will have different path line. So these individual particles will have the different path line depending upon the initial point of the motion. So if I say that Lagrangian in a Lagrangian approach, the motion depends upon the initial position. Secondly, at this time this particle is over here, this particle is over here, this particle is over here, this particle is over here. So after some time this particle reach over here, this will reach, and something like. So the Lagrangian approach, in Lagrangian approach the motion is also dependent upon second component, and that second component is time. Okay, so these are the two components upon which the Lagrangian approach has the dependency, initial position and the time. So once again I am reading out, in classical theory the Lagrangian specification of field is a way of looking at fluid motion where observer follows an individual fluid parcel, like in this boat is for this layer only, for this individual particle only, as it moves through space and time. Plotting the position of individual parcel through time gives the path line of the parcel. So if you will plot the path followed by this boat with the camera fixed, and that is recorded with the camera, so that will give the path line of that parcel. This can be visualized as sitting in boat and drifting down a river. So mathematically, if you say consider a certain fluid particle whose initial position is indicated by, it will be chi and initial coordinates x naught, y naught, z naught. Fine. At initial time t is equal to t naught, and let us say r at any point z, x, y, z be the position of the same particle after time t. At initial time the position is this one at time t is equal to t naught, and after time t the position will become this one. Okay, now we'll move further. Thus the position of the particle is completely specified if position vector r or the three corresponding coordinates x, y, z are function of time and initial position. So if I say that position of the particle at any time t is function of chi is the initial position of the particle and t is the time. So chi is the initial position of the particle. So that we have already studied that the position at any point in Lagrangian approach depends upon the initial position and time. So this is the position vector of the particle at any time t. This is the position vector of the particle at initial time. Similarly, this composed of three components 1, x, y and z. Therefore, if I say all these three components are separately function of the initial position and the time, so there will be no exaggeration and it will write. So that could also be put up in this particular form. So that will be further in the velocity component, you can write something like that. Okay, you have already done it. It is apparent that Lagrangian approach has many advantages. The motion and trajectory of each and every particle of fluid is known. Like in this case, this is the motion. So at any time, if you say that the motion and trajectory of each and every particle, like it has two particles, so at any time trajectory is and the position are specified for each and every particle. Motion and trajectory of each and every particle of the fluid is known, so that at any time t it is possible to trace the history of each fluid particle. Since the particles are identified initially and traced through their motion, therefore conservation of mass is implicitly followed. Like we have the trace, or you can say track of each and every particle at any time of the motion. So therefore there is no loss of the particle, there is no loss of the mass from the fluid motion. Therefore we can say that conservation of mass is implicitly followed. Conservation of mass is followed. And what kind? Implicitly. So these are the two benefits of the Lagrangian approach. One is implicitly mass conservation is implicitly followed, and the trajectory and motion of each and every particle is known. The one serious drawback is that that fundamental equation of motion in Lagrangian approach are non-linear. So whatever equation we will form using the Lagrangian approach, those equations will be non-linear, and you know that non-linear equation is very hectic job to solve. It is very tedious one at hand. So it is almost very tedious job to solve the non-linear equation, hence are difficult to solve. In fact, most practical application of this are limited to one-dimensional flow. So most of the practical application that we have got of the Lagrangian approach are limited to the one dimension only, not for two dimension or three dimension. Thus the other approaches for the higher dimensions are followed. So these are the two drawbacks. One drawback is that equation of motion formed by using the Lagrangian approach are non-linear, and non-linear equations are difficult to solve. Second one, the practical application are limited only to one dimensional flow, not to higher one. So for the higher one we have to use the different approach. So these are the two drawbacks of the Lagrangian approach. Now we will move towards the Eulerian approach. So in Eulerian approach, what is the difference between Lagrangian approach and Eulerian approach? We will study over here. The Eulerian specification of the flow field is a way of looking at fluid motion that focuses on specific locations in the space through which fluid flow as time passes. This can be visualized by sitting on the bank of a river and watching the water pass the fixed location. So the difference between the Lagrangian is that in Lagrangian, the observer was moving with the particle, like we were having this motion. So here was the boat, this is the boat, and in this boat some person was standing and was moving along the particle. This was the Lagrangian approach. While in this case the motion is being done and here observer is standing at a fixed place with camera in his hand, watching the motion. So for watching the motion, this much space is available to him. Whatever motion is taking place in this space is visible to him. So and he is recording the motion through his camera, like at time say t1 he takes a photograph of the motion. At time t2 he again takes the photograph of the motion. Photograph means the position of the particles, like the particles are here, and wherever the particles are there, that picture is captured. So in this case, in the Eulerian approach, the observer is fixed, while in Lagrangian approach the observer is in motion and moving with the particle. So this is the difference between Eulerian approach. In the Eulerian approach, the observer is fixed, while in Lagrangian approach, observer is in motion with the camera in his hand to record the motion. So that is the main difference. So like at time t, the position is here, and after some time the position of the particle will same. So if I say that the Eulerian approach depends upon the time and position of that particular particle at that time, it does not depend upon the initial time, because we don't know that when the motion and from where the motion was started, because we have this only field visible under observation. So only this much field is under observation, and that could only be recorded by the observer. So he has no knowledge that when and where, from where the motion was started. So it does not depend upon the initial position, rather it depends upon the present position of the particle, and that present position is the position of the particle at any time t. So the velocity of the Eulerian motion depends upon the position of the particle at time t and the time itself. So it depends upon two components. So that is the difference between Eulerian approach and the Lagrangian approach. So I hope that I will be able to make you understand the concept, and this will clarify all doubts in your minds, that what is Lagrangian approach and what is Eulerian approach, and how to discriminate, how to distinguish between both the approaches, and what kind of approach is being used in the given question. So that is all I have from this lecture. If you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying you goodbye, take care, bye bye, and see you soon.